In this video, let's look at scaling, specifically in the context of perimeter and area. We are given that rectangle A has dimension of 2 units and 5 units. So let's just write that down here, 2 and 5. And this rectangle is scaled up by a factor of 3. And rectangle B is a new rectangle. So this is the new rectangle. And if it is scaled up by a factor of 3, then this must be 2 times 3. So let's just write that here, 2 times 3. And this must be 6. So 1, 2, 3, 4, 5, 6. And the length must be 15 because 5 times 3 is 15. Yeah, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? So now we have to figure out the ratio of the perimeters of the two rectangles and the ratio of the areas. So let's kind of organize this well so that we can keep track of all our work. We have perimeter and area, and this is rectangle A and rectangle B. Let's figure out the perimeter of rectangle A. So rectangle A, one side is 2 and the other side is 5. So this side will also be 2 and this side will be 5. And so we have the perimeter of rectangle A would be 2 times 2 plus 5, because we are taking 2 plus 5 2 times, and that would be 14 units. So let's just write that down here. That is 14 units. And the area would be, basically the area of rectangle A would be 2 times 5, which is 10. And that is 10 square units. What about rectangle B? Again, before we actually launch into figuring out what is the perimeter and area of rectangle B, let's first think about what do we expect it to be. If we know that the scale factor is 3, we think that the perimeter and the area of rectangle B would be 3 times the perimeter and area of rectangle A. Let's see if that is true. First, let's figure out the perimeter of rectangle B, and we have 6 plus 15 taken 2 times. 6 plus 15 is 21. 21 times 2 is 42. So that is 42 units. And the area of rectangle B is 6 times 15. 6 times 15 is 6 times 10 is 60. 6 times 5 is 30. So that's 90. And that's 90 square units. The ratio of the perimeters is, we have to do new to old, and so we have to do B to A. B to A would be 42 units to 14 units, and if we simplify this, the units disappear and we have 3 to 1, which is the scale factor. What this ratio is telling us that B is 3 times, the perimeter of B is 3 times the perimeter of A. Now let's figure out the areas, the ratio of the areas. So the ratio of the areas. And again, we are going to do B to A. So B to A equals, B is 90 square units and A is 10 square units. And if we simplify this, we get 9 to 1, not 3 to 1. So the ratio of the areas and the ratio of the perimeters are different. The ratio of the perimeter is the same as the scale factor, but the ratio of the areas is different. I want you to pause the video right now and think about why is the ratio of the areas different and how are these two connected with each other? What's the relationship between 3 to 1 and 9 to 1? I will try and explain why the two ratios are different in two different ways. Let's compare this rectangle A and rectangle B. You have a 2 by 5 rectangle here, and let's see how many of these 2 by 5 rectangles we find in rectangle B. This is 1, this is 2, this is 3. So in the first row we found 3 such rectangle A's. Then we have 4, 5, 6, 7, 8, 9. So we actually find 9 of these rectangle A's in rectangle B because you have 1 here, 1 here, and 1 here. And that's just for the first row. And then that's the first row. Then we have another row of 3 and another row of 3. And so you have 9 such rectangles, and that's why the ratio of the areas is 9 times, while the ratio of the perimeters is 3 times. Another way to think about it is the way you find the area of rectangle B is you do length times width. Now, how is the length of rectangle B related to the length of rectangle A? So we take the length of rectangle A, that's 5, and then we multiply that by 3 because the length of rectangle B is 3 times the length of rectangle A. And then, so that's the length of rectangle B, and we take the width of rectangle B, which is 2, and you take 3 times that width, which is this. So you notice that we have a 5 and we have a 2, which comes from rectangle A. But then we have this 3, which has scaled the length 3 times, and we have this 3, which has scaled the width 3 times. And so you're actually multiplying 3 times 3 times the original area of 10 square units, and that's why you get 90 square units, or you get 9 times. What this basically means is that the scale factor gets multiplied 2 times. You're literally taking the square of the scale factor, and that makes sense because a perimeter is one-dimensional, but area is two-dimensional. It's measured in square units, so the scale factor is also squared. When we think about scaling and scale factors apply to one dimension. So scale factors or scaling applies to one dimension, which is length, width, perimeter. They're all one dimension. You can measure it using a measuring tape. But scaling does not apply to area. It applies to, the scale factor would apply to the length, and then it would separately apply to the width. And so when you multiply length and width, you've actually taken the scale factor 2 times. And that's why you would square the scale factor to find the ratio of the areas. So let's think about this a little bit more. So if the scale factor was, say, 5, then the ratios of the perimeters would also be 5. But the ratio of the areas would be 5 times 5, or 5 square, and that is 25. The area of the new image would be 25 times the area of the original image.